Hello Frank, today I would like to introduce you the project number 2 called Finite State Machine. This project is based on individual game called Snake. So the first part of the project is going to be introduction of electrical components that are involved in schematic in the circuit of the project. And the second part is going to show how the project is implemented by running the actual game, and in the end I will explain briefly the source code and the states of the game that are involved in order to execute in order to implement game engine. Okay, there are two main components in this project. The first one is Teensy 3.2 development board, and the second one is OLED display SD1306 that is connected through the via clock and data communication lines to our Teensy development board, and also it's powered by the VCC, the power supply from the board 3.3 volts. Next auxiliary one components is 5 switches. Each switch corresponds to direction of the snake, so it's an up, down, left and right, and this standalone switch is responsible for start, stop and pause of the game. Also, the last but not least is our two resistors of 360 ohms. So it's used to stabilize voltage at clock and data lines, and it eventually evens out these two signals lines. Here we go. At the very first time when the game is powered up, and at first run it shows up the snake start screen, as you can see, and the user interface text press start button. So I'm pressing start button, and there's a small snake that starts moving, and as one of the game requirements is to move, the snake is able to move beyond the boundaries of the screen, so it's implemented successfully, as you can see. And also the snake can eat food very easily. With two eaten food parts, the speed of the snake will gradually increase, and as you can see, the speed has increased slightly. And if you want to pause the game, you can press the pause button, and here you can see your current score and the user interface, what to do next in order to continue to resume the game. So in our case it's press start button, so I'm pressing start button again, and it resumes where it left the snake. And then as you can see, the speed increased once again. And then in order to fail, the snake should collide with its own body. And as you can see, when the snake collides with its own body, the game over screen pops up, and it shows your score and what to do next in order to start a new game. So after that I can press the button and it starts over again. So it starts over from starting speed, and then also once again I failed it, and yeah, it shows just 2 score. So that's pretty much it, and next we will move to source code explanation. Okay, here we go. At the very beginning of the source code, you can see the date of completion and the brief description of the project and the main feature that it includes. Next one is going to be our data communication and hardware specific libraries that includes wire, Adafruit, and Adafruit specific for display. Next one, my created bitmaps. I've put them into header files and include here. Then it's just configuration for the LCD for the display. Next one is creating of display instance by calling display and passing the value number 4. And then our, as usual, digital pin allocations for buttons. These two are responsible for creating new data types, namely one is for our state of the game and another is for the buttons, namely for the movement. And this one we create the variable for newly created data types. And here we create the boolean variables flags, debounce timers for buttons, play result, one array for the screen that bears in first array X position of each display segment and then Y position, and in each of them we have snake data where it's all explained here. And the next one is our variable for head and tail and foot position. And in setup function it's all initializes all the pin modes, all the flags, places the snake into position, places new food, also attaches interrupts. And here's our loop main function basically. So at the beginning of loop function you can see the bouncing procedures. So the first one is for start stop pause button, and the rest of them is for up down left right. And the most important part is our switch statement with a game state variable. So it looks into state of our game, and based on that it will execute different function procedures. So as you can see, start screen, pause screen, game over screen. In move snake it's most massive one, and then eat food, place food, and that's pretty much it. After that it just goes our function that is in case statements over there. So all these functions are pretty self-explanatory and doesn't require huge comments, because I've tried to keep that simple and explicit. So by reading each name of function you can easily understand what's going on with our code. As you can see, calculation position of snake body, so it's self-explanatory, and then it's all includes, and then drawing and displaying snake, head body collision check, food check food, eating current food, placing new food, check position of food, show scroll on the screen. So it's again all is self-explanatory, and in case I've put some additional comments on different lines just for additional clarification. So that's pretty much it. Okay, this is our last part. So we've discussed what the electronics components involved in the project, the actual running of the project, and the brief explanation of our source code. So it was the last project, and thank you for your attention, Frank. I hoped you enjoyed this video, and see you next time.